Hello friends, Sabko Namaste. So today in this video we will create a chest X-ray classification model which can classify that the particular chest X-ray have a disease pneumonia or not. For that we use YOLO model. I just copy the share link of my dataset where it is uploaded and just kept a small part of it, just this much, and copy here. And your dataset, after when you run this set, you will see that a zip file is uploaded here in Google Colab. Okay, just run this cell. See, it's downloading. You can see it. Your zip file is here. Now you have to unzip it. Okay, let me show you a data set. So this is a data set chest X-ray which contain two folder, train and test. In train you can see the two folder, normal and pneumonia. In normal you have a chest X-ray with normal chest X-ray, and in pneumonia you can say have a chest X-ray with pneumonia in it. Okay, and you can see that the number of images is 15 in this, means 1500, around 1500 and 1400 images are like here. Okay, now let me go back to the and this is a library package, you can say, from where we can import the YOLO model. Now from uploading the pre-trained model of YOLOv11, we have to use from Ultralytics import YOLO, and model is equal to YOLO, and the model which we are using is YOLO11L. You can see it, YOLO, you have multiple models of YOLO11, and it is N, S, and M and L, and the model which we are using is YOLO11L. Its parameters are 12.9 million parameters, and it is the size on which it is trained is 224. Okay, now after uploading it we have to use it on a custom dataset. For that we have to use model.train. Just give the folder name in which you in which your dataset is present, just the same name. Then the epoch is 50, but I already have a you can say a model which is, or a parameter file or weight file, you can say, which is trained on 50 epoch. So I will upload that upload that weight file and show you the result of that. But right now I just want to train it on 2 epochs only, or you can say 3 epochs. The image size you already know that it should be 224. The batch is 8, means when an images is divided into a batches during training, I wanted in each batch I want 8 images should be there. And name chest X-ray dataset. This is a, you can say, the folder name, means when you run this cell you will see a run folder is automatically created inside a run folder. Classify folder will be there, and inside the classify folder one folder is there whose name is decided by us, and it's I kept this name is that. And inside this folder you will see a weight folder will be there. Okay, which contain the weights file. Hey, yes, save true. Yes, we want to save the model. Save period -1. Yes, means it's showing that we do not want to save every epoch weight file. We just want to save the weight file which have a highest accuracy, or you can say where the loss is minimum. Patients 20 is early stopping, means after every 20 epoch it see that there is any performance is good or not, or you can say it see the accuracy is increasing, or the you can say a loss is decreasing or not. If it is not decreasing or the accuracy is not increasing, it will stop the AR training, and weight file which have a highest accuracy will save. Validation true. Yes, we do not want it because we do not have a folder like this. But if you can but if you have a number of images is high, you can use val is equal to true. It automatically divide the training data set into 2080 ratio, and the training going on. But right now I don't want to use validation. And after that you can see there is only a chest X-ray images, but I want to add some variation, means rotation, flipping, everything I want to add, so the variation of the images is increasing. For that I have to add data augmentation. So that's why I use degree, flip up, scales, and translate. So here I added the data augmentation. Now let me run the cells. You can see training gets started. You can see the run folder is automatically created. See our training gets started. Here you can see a GPU mem is GPU memory which is required during training. Loss is the classification loss, and here 383 basically the batch size in which 8 images, every batch contain 8 images. Okay, now let me show you after the training gets over how we can load the model. See, first we have to give the model directory, or you can say weight file directory. So I already told you the run folder contains the weight file. So inside the run folder, classif folder, inside the classif folder you will get the which is decided by us, and inside that we have a weight file, and inside the weight file you will see the weight file. It is of inside the weight folder, you can say we have a two file, best and the last, and we want best pt. So this way we load the pre-trained model which is trained on a custom data set. Now we have to give the test directory. This is a test directory. You can see that in a test directory it's contained two folder, name, normal, and a pneumonia. So I have to make the list of all the folder name present in that particular directory. So it will make the list of that folder. Now I will tell you the reason why I make the list of this. Okay, before after in the code. So I want to plot 16 images. So for plotting of 16 images, I want 4 rows and 4 columns. For that, I have used 4 rows, 4 columns, and each of figure size 16 by 16. And for the plotation, I have used Matplotlib plot.subplots. Okay, now ax.rebel is basically used for the iteration over the subplots. For the plotation of the 16 images, I have to iterate 16 times. So after iteration of 16 times, first I have to select a random folder, means whether a folder is normal or a pneumonia one. Randomly I want to select it because I want to I want a prediction on all the, I want to check the predictions on different images. So I want both images, at a normal image and pneumonia images. So that's why I have to randomly select the folder name. After selecting the random folder name, I want the list of all the file name, image file name which is present in that particular folder. For that I have to use old list directory and just pass the directory. For that I have used over pass join, then test image folder, then the image folder randomly select by us. After getting it, I want to make the image path. For that I have to use over path join, just give the test image folders, then the image path image folder, then the randomly select the image file from this list. After getting the image path, just read the image. Now here just you can see I have passed the image path, not the image, but there is no problem. It's up to you whether you pass the image or the image path. It doesn't throw any error. Now let me show you the result use of 0, means I only passed the one image. So after prediction, to get the result of the one image, I want the 0 index value result only. So that's why 0 here. Now let me print all the things that what is happening in after it. Let me first print the result. Yes, I want to print all this result props, then result prop dot, not top 1 top 0, just as I don't want. Let me print the result, and before that I want to print model dot name. Okay, so that I can show you how the I retrieving all the information in these 3 lines, so that you will does not get any confusion. Let me break it so that I only one iteration. Let me first check that our training is completed or not. It's going on. It's already finished. Wait for it. So let me explain you, like orally I will explain you that result basically result.prop.top1 basically give me the class ID. After that, using class ID, model name give me the class name. After that, result.prop.top1 dot item just basically give me the confidence. After that, I just want to see, I have read the image in CVT format, so I had to convert it into RGB. So that's why I'm converting here using CVT colors. Now just plot the image. Then for the set title, I have to check actual and predictive board. And actual basically you already know that the image folder. Image folder define basically the actual prediction. Then the predicted by the model is this one, and the confidence is this one. Now, yes, training is get completed. Now let me run this cell and show you the result. What is the problem? Yes, this is a directory problem. The dataset folder is not there. Now let me run it. See what is see model dot name here. Model dot name give me this thing: 0 class ID belongs to normal and 1 class ID belongs to pneumonia. Then after I have that, I have print the result. The result is start from here, Ultralytics, and these are the parameter. You can say parameter, or you can say not parameter. These are the attributes. Now, main thing basically after means the result, or you can say a prediction, basically store in this attribute props. So result dot props give me this thing, this data tensor top one top gun confident means you can see that we make a list of both. This is the probability that a particular zero index, in zero index we have a normal. So how that what is the probability of that particular image belong to normal, that what is the probability that particular image belong to the pneumonia. This showing is this, and the highest probability basically give the confidence and the class ID. So top one will be 01. You can already see that here is 3.0 and the 0.6 and 00, which is higher. This one is higher. Already seen that top one will be 1. Class ID means and top confidence will be 10. So this way we retrieve the information. Now let me comment them all and show the result of the prediction, which is of the model which is trained on the three epochs. Let me run it. Pneumonia. Let me see how many predictions are wrong. Correct. I think all are correct. No. Somewhere are wrong. In 16 images, I think so all predictions are correct. Okay. All predictions are correct. Now there is no need that I will upload the model which is trained on 50 epochs. Training with 3 epochs is also showing the best result. You can use it and upload it anywhere where you can you want to make any bot or a Telegram bot or any web app or any software you want to use, where you can use this model for a chess XA classification. So this is the whole code where I explain you each and every line. So please like, share and subscribe. Thanks to all.